Hello everyone, and welcome back to our session again. Today we have our great external speaker. She is an entrepreneur, a director, and a certified trainer. Hope you will enjoy the session with us and stay tuned. Samara, the platform is yours.
Thank you. I'd like to welcome everyone in our today's session, in which we will discuss the interaction between humans, machines, systems, and how can we get the best out of them in terms of safety and productivity. So I hope you will enjoy my session. So we'll be talking about industrial safety, organization, technology, and human factors, and how can these all together affect the safety and harmony of production within the workplace. To explain human factors engineering, which will be the focus of my presentation today, we need to all of us agree on the principle or the main principle or definition of human factors. It's actually relatively considered as a new science, even though it's not really new, as we will discover very shortly, and it's applied in many various industries. It's proven to have very good results in terms of optimization of resources and quality, as well as reducing accidents and occupational illnesses. Human factors engineering, as I said, it's considered to be a new science or a new field, even though it's actually not really new, because it is the interaction of a lot of all sciences, as we will see here. So for example, it's the integration of engineering science, where we talk about the design, whether it's the design of a machine or a building or equipment that we use. Also, it has involvement of the management science in terms of policies and procedures of workplaces. Law is also part of human factors engineering, where we have the enforcement side of procedures and policies. Also, psychology and sociology play a role when we talk about human factors engineering and their impact on safety and productivity. Medicine and health science, because here we are considering human body limitations and abilities, and indeed safety and equality. Very shortly, we will talk about each one of these sciences and see how it is related to human factors engineering. So to start with engineering, how it plays a role or part in human factors engineering? Well, first of all, when we design a machine, we need to consider occupational illnesses, possible occupational illnesses and disorders from using the tool or the machine, considering the human body needs and abilities. When I design the gauges and the keys, I need and indicators of a machine, I need to see if they are noticeable by the user, considering human ability and needs. Color coding and size and location of the keys and buttons of a machine when it's designed. This is an engineering principle, but it has impact on human factors engineering in terms of reducing the possibility of human error, or we call it human failures. Also, it's important when I design a machine or a building to consider or ask myself the question whether it is possible to maintain or clean even this machine or building safely, or is there a better way to play with the design to make it safer for the person who's going to maintain it or clean it. So in the beginning, I was talking about the user, but here I'm talking about the person who is using the machine or the person who's going to maintain or clean. I consider all of them. Also, it's very important within the machine, and we see this a lot in the modern and the new technology, where you have safety devices where the machine or even the car will shut down or stop when there is illogical order given by the user due to human error or confusion, lack of knowledge. Also important to consider that less effort is required to operate the machine or the equipment, considering the human body abilities and limitations. About management policies and rules, how this can be a part or integrated with the human factors engineering. Indeed, it is here we talk about staff consultation. So here we talk about the management side within the organization. How can this play a role in reducing the accident, considering the human factors engineering? When you consult your staff, before making decisions, when they are part of decision-making process, it's very unlikely that they will break these rules. And it's very likely that they will support you to implement them, and they will report to you any gaps within your systems. They will feel that they are included and they are part of the organization. So this is a very crucial part within the management and policies. Also, we need to consider the application of rules, whether they will be applicable, user-friendly. Are they safe rules? As we will talk shortly today, sometimes there's a problem with the rule, not with the person who's following the rule, but the rule itself was not designed in a smart way, which led to a human error or accident. Within companies and HR systems, the rewarding systems have to be designed in a very careful way, in a way that we don't reward people only for production, regardless whether they have done the work in a safe way or not, because this can lead to a disaster. I'm sure you all agree with me. So we need to consider or balance both, having the rewarding and punishment system in a very balanced and transparent way and done very carefully. Also, it is the responsibility of HR department to make sure that the right people are doing the right job. So they choose the right people, not only in terms of the physical ability, but a lot of other abilities. And there are a lot of famous tests nowadays to see the suitability of the person for this kind of job or task. Training plans for staff plays a role in terms of human factors engineering, and it's part of the management responsibility, particularly HR, but even line managers, because here we see the capabilities of the people and the gaps. When I say training, I don't only mean safety related training, but if the person is more skilled to do the work, they are less likely to make accidents, like the car driver, for example. And peer pressure consideration is a very important thing to consider in when we design the work systems and plans and distribution of staff. By peer pressure, we mean it's the impact which the group has on the individual, whether positively or negatively. So if we have a safe person and we put him among a group with very unsafe acts, it's most probably the one single person will be affected by the group by the behavior or attitude of the group. We have to be very careful with this. So maybe we have these people with groups with unsafe acts to be distributed within other groups which are well known to be safe groups. Hopefully this will change the attitude of these individuals. We have to be very careful with the peer pressure effect, because it can make our life easy or difficult in terms of safety or even productivity. Here we talk about psychology and sociology relation with human factors engineering. Basically, here we talk about human nature and society natures. So we need to be careful here to consider how can we reduce the chance of violation of rules. Why people violate rules? Why do they break rules? They behave in groups, or how can we make the group believe in what we believe? How can we change their behavior and their attitude? It's a big topic, by the way, we can't cover it today, but changing behavior and changing attitude is a very important area within health and safety. How can we motivate the people to make them follow the instructions? It's not a matter of ordering them. They need to be motivated and believe in what plans that we put in place. Otherwise, there is no point. How can we utilize peer pressure positively? As I mentioned just now in the previous slide, peer pressure could play a positive role if we know how to use it positively and enhance the positive behavior among the group. We need to understand psychologically how does the human brain work, and consider that when we design the action and time scale for the job. As you can see in the slide here in the diagram, this is the machine or device and this is the human. So if there is an output or a signal coming from the machine, for example, a strange noise or vibration or a warning sign, how will the user, the human, will receive this through his senses and going to the brain, cognitive process, analyze it, try to understand what is this about, and then give the right action to the body, whether it's the hand, whether it is the feet to press the right brake, or a button and take the right action, maybe press the shutdown device or whatever, or emergency device, and take the right action as an input to the machine. And then here we have the processing and reaction between the machine and the human. So it takes time, and if anything goes wrong in any of these steps, a human error could happen. So if the person doesn't receive the signal because of his abilities or hidden disability, or he has a problem with the analysis process in his brain because of his knowledge, or because he's confused, or because he's under pressure, it could go wrong. And then what is the correct action for that diagnosis? All these, or maybe after, even if he realizes what is the right action, did he actually press the right button? Was the button or operation system or dashboard clear enough in front of him to enable him to press the right button and take the right action? So it's a very complicated process. If we break it into small parts, we will see that if anything goes wrong, we might have a human error. Accordingly, we should consider all these steps if we want to reduce this possibility. So signs have to be designed logically, as I said, so they can be easily identified without much time. And we need to also ask ourselves, okay, we designed the machine thinking that people will use it in this way and stand in this position or sit in this position, but actually taking into account the human nature and how people historically used to use machines. How are they most probably going to use the machine, in which position? And how would also people or might get it wrong by reading our instructions, and how can we make them more user-friendly and less likely to be misunderstood? Medicine, I've already covered this indirectly when I spoke in the previous slides, and here we will talk about occupational diseases and illnesses from using the machine or system. By the way, we're not talking here about machines only. We talk about even work pattern, shift systems. Is it going to help the person to have enough sleep, taking into account the biological clock of the people, their needs, their social needs as well, not only body needs. This is here where we see the interaction, exposure limits and safety to the noise, to the light, to the vibration of the systems, of the machines. We have some invisible disabilities or special needs, such as dyslexia and color-blinded. People who are color-blinded cannot see the color-coded buttons. So we think we are communicating to the person or to the user the right way of using the machine, but in fact, it means nothing to them because they can't differentiate the colors properly, or they can't read the instructions clearly, especially if they are under time pressure and if there is emergency situation. People will panic naturally. So if they have these kinds of invisible special needs or disabilities, it will definitely make it worse. And as I explained in the previous slide, the harmony of how senses get the signal and the brain analyzes it and the intact action is taken, how this can work in harmony. I'm talking about the physiological side and medical side and not the psychological side only. How much does it take the person to respond? So the speed of response and average human ability and needs. Of course, people are not exactly the same, but we have general average of, for example, the range of vision for the people, how much weight they can carry, how many hours they need to sleep, so on and so forth. So this needs to be taken into account when we design the system considering medicine. A very quick example about one of the famous applications of human factors engineering, it's the traffic light systems. Safe explanatory pictures here. So traffic light systems, how they are considering human factors engineering. For example, in terms of the timing, how much time does it require for the driver to respond psychologically and physiologically? Psychologically is when he will think about it or when he will understand, and physiologically is how much does it actually take him time to, for example, press the brake. Okay, there is a time limitation here, and both of them need to be considered. So accordingly, traffic lights, to avoid accidents in intersections, these are definitely considered. The location and height of the traffic light, and the vision range of the person. So if it's too high or if it's too low, what is the likely average height where most people can notice it and how far they can see it? So this is the range of the vision. If we have too many signs, as we can see in the picture, for example, it's going to be confusion to the driver. So is it better to distribute them? But if I distribute them, is he going to notice all of them one by one? What is the right thing to be done? Quality and clarity of the traffic lights, as we can see, some of them are damaged, but some of them are not really damaged, but they are just faded, or you have the light reflection of the sunlight on them. So people and users cannot receive them. Don't forget that traffic light is a means of communication. So it needs to be ensured that it's clear. It needs to be in logical order, in line with the way a human brain works, and designed in a very careful and smart way to reduce the chances of violation of rules. So this is about human factors engineering. We want to focus a little bit more about our topic today, which is human errors and accidents derived from human factors. Statistics suggest that 80% of accidents actually are due to human errors, and 20% are due to equipment failures. When we say human errors, we mean human failures generally. I will talk about this very shortly. What is the difference between human error and human failure? But because humans have done something wrong, let's put it in the simple words, 80% of accident, 20% because the equipment failed. However, most of the failures of equipment are indirectly due to human errors because there are mistakes in design or installation or maintenance or use. So in a way, most accidents are due to human errors. It's good and bad news because if we know the reason, we most probably can control it till some extent. If we take this 80% of human errors, statistics suggest that 70% of human errors are not actually the fault of the worker or employee. It's actually the fault of the organization. So there are problems in the systems, as I said previously, work pattern, duration of breaks, the way you design your shifts, the way you communicate message and instructions to your staff. So they might end up making a mistake because they misunderstood your instructions, because the means of communication wasn't very effective. And 30% of accidents are purely due to individual failure or human failure. This is a very interesting chart where we see when we talk about the human energy level, because here we are focusing on the humans when they make mistakes. We need to remind ourselves that there are levels of the energy of humans. One which we always focus on is the physical energy, the body ability. However, there is the emotional energy, is how I feel. It could affect my actions. So I could fail because of my physical energy, because I don't have the capacity to lift this load, or I have a hidden disability or obvious disability that I cannot see the sign. That's all to do with physical. Emotional is because I felt so stressed or very happy or very excited or very sad. I failed to, for example, diagnose a particular problem, so I took the wrong action. The mental energy is when you don't have any emotional or physical limitations, but you are just overloaded. They keep on interrupting you. For example, it makes you, or it leads you to make a mistake, or you lapses of some steps within the process, as we will talk very shortly. And spiritual energy, and this, in most cases, we can utilize them positively, where people have more motivation because they believe in something and they are motivated to do more or to go beyond their limits. And we all know experiences where we have been through such situations. So the decision maker or safety professionals have to take all these into account in order to reduce the likelihood of human errors. Human failures and human errors, as I told you, there's a slight difference between them. Human errors are part of human failures, where human failures include both deliberate and undeliberate actions leading to losses. So error is for undeliberate. Deliberate, we call it human failures. that's the difference between them. So for example, deliberate means violation of rules when the person decides to ignore safety rules. And deliberate human errors when the person by mistake take a wrong action leading to accident, and it has many types. So, statistics suggest that the vast majority of accidents are related to skill-based tasks. I would like to explain this briefly. What do we mean by skill-based tasks? These are the tasks that the person will require to do when they are very, very familiar with the task. So they become a kind of program to do it without really giving much attention because they do it all the time. It happens with very familiar situations, very familiar tasks. It is good when the person is very skilled and can do the work with very little attention. However, very little attention is a problem because sometimes you have unusual situation will arise or emergency situation, and people will do a mistake because they don't have enough attention to the task. Rule-based is when the person applies the rule in a wrong way. And knowledge-based when the person fails to identify the situation properly and take the right action because of problems with the person's knowledge. And very few of them actually lead to real accidents. So a lot of these mistakes, luckily, they lead to near misses, not real accidents. This is a very wide and detailed chart about human errors. So I will just focus on the headings. So this is the human errors, and this is the unintentional type of them, and this is the intentional. As I said, intentional are called deliberate, and they are non-compliant with the violations, so ignoring the rules by the users. Unintentional could be of two types. Mistakes or errors that are related to execution. So I do something by mistake. For example, I pressed the wrong button. I was intending to press on, but I pressed standby, or press off, but I pressed on, and this might lead to an accident. So this is the slip. Lapses is when I omit a step within the long process. Slips usually happen because lack of focus. So I don't look to the keyboard in front of me because I am too confident. I'm very familiar with the task. That's the main cause of slips. Lapses usually happen. I am too familiar with the task and someone interrupts me in the middle, or I get a phone call. So I meant to switch off the device before I go home. I forgot it because I was under the impression I did that. However, the phone call interrupted my thinking process. Thinking error is related to rule-based mistakes and knowledge-based mistakes. Rule-based mistakes is when someone follows the rule in the wrong way. So they have wrong understanding of the rule. So they are under the impression that they are doing the right thing, but they were doing the wrong thing. And knowledge-based is when they take the wrong diagnosis, like the medical, for example, errors. So it's wrong diagnosis because of shortage in knowledge, and usually these both happen in unfamiliar situation, mainly with the rule. Knowledge-based, sometimes it happens with the familiar situations, but sometimes also with the new situations. This is a quick idea about them. Just a quick reminder to us about violation of safety rules, that safety rules or signs could be of three different types. The main types: prohibition, when you are not allowed to do something; mandatory, when you are required, you must do something, usually in blue; and warning is in yellow, when we warn the person, for example, slippery floor. Violation of rules, and this is a huge problem in all societies. Why people break rules, even though we have told them this is unsafe, and they have seen the statistics. Why? Most of us tell themselves or tell ourselves that this will not happen to me. We see a video, or we know, or we hear about a case of someone that we know, he was texting and he was in a major car accident. The next day, most of the friends will do the same, thinking that this will not happen to them. This is the human nature. And sometimes we don't want to know because we are happy the way we are. So we don't want to put the seat belt because we think we were driving for the last 15 years and nothing happened to us. So why would something happen now suddenly? This is one of the challenges for management, managers, decision makers, enforcement authorities all over the world. We are not talking only about occupational health and safety. We talk about general safety of the society, of public safety. Sometimes, however, we need to think that maybe there's something wrong with the rules. So the rules are not very communicated very clearly, or they are not clear enough. They're not user-friendly. They are too complicated. People can't read 200 pages. So the way we communicate the rules, the way we put them gradually, that's very important also. Sometimes people ignore the rules because, for example, I want to come from this entrance to my workplace. It's very quick and close to the parking area, but the rule tells me that I have to walk for 200 meters around the building to use the other gate. So I will maybe decide to ignore it because it's impractical to me. Unless there is very strong justification, we need to make people's life easy, and the rules are very smooth and user-friendly. And sometimes, of course, people have the wrong attitude towards rules. So we need to have a proper supervision, disciplinary actions. And as I said, HR can play a big role in rewarding system, rewarding people who report unsafe conditions and accidents rather than punishing them. No blame culture is a golden rule in order to encourage everyone to follow safety rules and report gaps in the system. Thank you very much for listening to my presentation. I hope you enjoyed it and wish you good luck for the rest of the event.